Hi, welcome to Scholarden. In this video, we will learn about the drift velocity and understand the mechanism of the current flow. Now, we are going to talk about the mechanism of the flow of electrical charges in metallic conductor. So first, we are going to talk about the metals because the number of free electrons are present in the metals. So in the metals, nearly 10 raised to power 28 per meter cube number of electrons are present. These are your free electrons. Now, in absence of electric field, it means when electric field is not present. When electric field is not present, then there is a continuous random motions. So there is a continuous random motion due to thermal energy. So there is a continuous random motion due to thermal energy. So there is a continuous motion, random motion due to the thermal energy. Now they are moving randomly in all the directions. So here what's happening, the motion is in all the directions. They are moving in all the directions. In all the directions. In all the directions. Right? So from here we can say on an average the number of electrons traveling in any direction will be number of electrons traveling in opposite direction. So we can say on an average, this is the on an average number of electrons traveling in any direction is equal to number of electrons traveling in opposite directions. Traveling in opposite directions. Opposite direction. So what we can infer from here, that if we are going to assume the average thermal velocities, suppose I am writing as u, so u is equal to u1 plus u2 dash 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 un divided by n, and this value will come as 0, where this u1 comma u2 dash 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 un are the random velocities of n electrons. So these are the random velocities of n electrons. Clear? So at the room temperature, basically this all we have done at room temperature, the average thermal velocity is 0. So it means u average is equal to 0. What is the condition? At room temperature. At room temperature. Clear? Now, what's happening in the absence of electric field? Let's take an example. Suppose this is any conductor here. Cross section area is somewhat like this. Now how the electrons are moving? First electron is moving like this, in this direction. Second electron is moving in this direction. Fourth electron is moving in this direction. So like this, there is the random motion. This is moving this direction. So what's happening? They are colliding. Every electron is being collided by some other electron like this. So then V average or thermal velocity becomes 0. But when we apply the electric field, now what's happening to this conductor? You are applying the electric field. So electric field is being applied. So when electric field is applied, then what's happened? The force starts working on them. So here the force starts working. Now according to the concept of the force, we know that F is equal to QE. So what you can write, F, now this force is acting on a single electron, I can write as minus E. Now from here what I can do, in place of force, I can write mass into acceleration, and that mass into acceleration is equal to minus E. So by using this expression, I will get the value of the acceleration, and that acceleration will be A is equal to minus E by M. Now by this acceleration, suppose this is your electron number 1, by this acceleration it starts moving. Now after this acceleration A, these free electrons becomes guided now. So free electrons, now this will be guided electrons. So they are guided, they start moving in the particular direction. Now it means now the shape of the conductor will be somewhat like this. This is your any cross section area. What you have done, you have applied the electric field. That's the meaning of the electric field, that here you are going to apply the electric field. Now what's happening, these electrons become guided. It means electron starts moving from here. So this is the direction of the electrons here. Then they move it like this. So electron starts moving like this, they will start moving, and then they reaches at this end. So they becomes guided here. So when they are moving, so what is the main condition here? That here acceleration is there. In this case what's happening? Acceleration is present. Right? Let me assume, let the initial velocities of the electron is u1, u2. So these are the initial velocities here. u1, u2, dash dash dash, we are assuming is the initial velocities. Initial velocity. It means when electric field was not applied. Now we can use this equation because acceleration is present, so we can use this equation, V is equal to u plus at. Here they will move with this constant acceleration, so I can write V1 is equal to u1 plus a, and then I can write t1. Then V2 is equal to u2 plus a t2. Like this, this equation will keep on moving. So I can write Vn is equal to un plus a tn. If I will add all these equations, I will get the somewhat equation like this: V1 plus V2 dash 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 Vn is equal to u1 plus u2 dash 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 un, then in brackets, then plus a, and here I will write t1 plus t2 dash 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 tn. Now dividing both sides by n, divide it here by n, here also divided by n, and here also divided by n. Now this velocity here will become the average velocity, and then this whole term is known as drift velocity. Now this is your average thermal velocity, so this you can write directly at 0, and this will give you the concept of the relaxation time, average time, and it is known as relaxation time. relaxation time. So here what we can write, from here we can write the equation Vd, then average thermal velocity, that is 0, plus acceleration into tau. This you can write. But you know it very well that we have already calculated the acceleration, and value of all acceleration is F. You have taken use this equation, F is equal to ma, and state again that is equal to E. So from here your acceleration was E by m. So from here Vd is equal to E by m into tau. So this becomes our expression for the drift velocity. So now what is your drift velocity? It's a constant velocity. It's a constant velocity by which the electron moves, in presence of electric field. And how you are defining the relaxation time? This one, relaxation time it is the average time between two successive collisions, successive collisions. Thank you.